Okay, good morning. I am trying some new programs today so that you can see the screen better. And then eventually, I think I'm going to have to move to YouTube. There's some advantages to that I've learned about. So for now, I'm going to do this today and see where I'm at by the end of the week. But I'm going to try this and see if this works better for sharing information with you. So today, we're going to, the new topic will be sources of light. What I want to do before I get into that is just go back and talk about yesterday's lesson for a moment. So, yesterday's lesson is teaching you how pigments, these molecules that exist in the natural world, take visible light and reflect some of the elements of the visible light and absorb some elements of the visible light to produce the different colors we see all around us. I left you with a chart where it said if this is the color of the object, what are the pieces of the white light that are being absorbed and what are the pieces of the white light being reflected. So I'm going to go over here, and you don't need to write this unless you want to, just to review from yesterday. Let's take a shirt. It's a shirt. And let's say that it's in white light, it looks like cyan. Okay. So white light, we've talked about, has all the elements of the rainbow, but we've been breaking it down into the three primary colors of light, which are red. It's a new pen too, guys. Green and blue. All right. So on the cyan shirt, you're shining white light. The reason the shirt looks cyan is because the pigments that were used to dye the shirt are going to reflect the two colors that combine to look like cyan. So that would be green and blue. So those two pieces of light are reflecting off of those molecules into your eye that looks like cyan. What's been absorbed is red. Okay, so that's what you were practicing yesterday. We looked at something that's white, what that means. I left you with that. Something that is white means it's reflecting all of the colors. And so it's not absorbing any energy. So these things tend to stay cool because they're not taking that energy from the sunlight and taking it in and holding onto it. Things that are black, they're absorbing all the colors from the visible light spectrum. So they will heat up. Think of like pavement in the summer or something like that, or a black sweatshirt on a hot day. The difference between that and like a white t-shirt. So dark colors absorb more, so they will also take in the energy and convert that to heat, whereas lighter colors reflect more. And so they tend to not heat up or stay cool as a result. They are not absorbing the energy. All right, we're going to take it one more notch. It's a little bit more complicated. Your book has a couple questions like this. Let's take the same shirt, and here's a twist on this. So if you've understood everything to date, oh, big shoulders on this shirt. Anyway, it still would look cyan as we did before in white light. Okay, so we know what those pigments would do when exposed to the full spectrum. Here's the twist. Instead of shining white light on this shirt, we shine just a pure red light. Okay, so we control the pieces of the spectrum we're shining on it and we limit it down to red. Based on this example up here, you know that the shirt absorbs red. So all of the light is going to be absorbed, nothing is going to be reflected, and this shirt will look black in this weird, contrived, manipulated situation. Okay? Because the only color we put on those molecules is the color that they absorb. All right? Let's take another situation like this. Same shirt. So we know, and you can only do this when you know what it does in white light. So in white light, we know it looks cyan. Let's say this time I choose the color blue. That's the only light color I'm shining on it. I have a pure blue light. Based on our experience up here, we know that the shirt will reflect that color of light. Those pigment molecules in the shirt reflect blue. So that blue light is going to be reflected and it's going to look blue. Okay, so we have one more layer there of complexity to the additive color lesson. Okay, we are going to switch now into a new topic, and that is production of light. Okay, so brand new. This is in your textbook. It is section 10.2. I'm going to pick and choose some of the light types to focus on for today. So let's call this, let's call it light sources, or sources of light. Sounds better to me anyway. Sources of light. Okay, before we start, there's two terms to define. The term luminous, Luminous, and non-luminous, NON, with a little dash, luminous again, Luminous. You may remember these terms from space, depending on how your teacher defined some things and got into some things. So luminous is an object that produces its own light. Produces own light. So when you talk about space, the luminous objects would be like the stars. They are creating their own light. They're doing so through nuclear fission reactions, but that is how they are producing the light you see in the dark night sky. Non-luminous objects would be things like the moon and the planets. So when you look at them in the night sky, you see them shining out there, you see light coming off of them, but that light is not because they produce their own light. And if I ask this to you in class, most of you would be able to tell me the reason why you see them if they're not making their own light. And that reason would be that they're reflecting the light of the sun. Right? So the star, which is the sun, is producing the light. You have the surface of the moon, which is reflecting those light rays off of it, and that's why we see it in the night sky so bright and beautiful. Okay, so non-luminous objects are giving off light by reflection. By reflection. Right? And so those words absorb and reflect should be pretty standard to you now, and you should be really comfortable with what those mean. All right, so we're going to do a little chart here. We're going to talk about different ways things produce their own light. So we're going to put a title here called source. And then we're going to do a little description. Okay. And then I think for today, I'm just going to call this other. It's a pretty poor title, but we're making do. Okay. So the first kind of light that I want to talk about is incandescent light. So this is called incandescent, spelled INCANDESCENCE, incandescence. This is the kind of light that you see in the old-fashioned light bulb. So if I were to draw a little picture here of a light bulb, there we go, little metal base to it. So new lights look like this shape now too, but maybe there's still a chance somewhere in your house you have a lamp or a light fixture, or maybe the light in your oven is this style still, where there's like a little metal piece at the base here to screw it into the socket, and then this is glass. And then with the ones that are transparent, where you can actually see through the glass, you would see like some fine wires or pieces of metal, say like they look like this. And then there's this thing we call a filament, and it's an even finer little wire that like goes across like that. When the light bulb is working, what happens is the energy passes through the light bulb. So it sort of follows a circuit, which means it goes up, goes across, comes back down, and it's all hooked up to the wiring in the house. But the current is flowing through, and when it flows through this little wire, it's made of a different material, a different metal, that when electricity goes through it, it gets really, really hot and it gives off light as it heats up. So that's what creates the glowing, that creates the light that is given off by the light bulb when it's turned on. Light bulbs of this style only last so long, and that's because these wires will only go for, they have a lifespan, and eventually they break, they burn out, they break. So when your light bulb burns out, if you were to take that light bulb, unscrew it, and shake it, you usually hear this little piece rattling around, or you can see that it's disconnected. So it's no longer going from here to here, it's become broken. And that's what burned out the light bulb. And then you get a new one. So we're going to write on here that how this works is this little metal heats up and gives off light. Another common place that I can think of that you would see incandescent light would be inside your toaster. So it's sort of a similar idea. In that case, though, it's not so much the light that you're looking to get, but the heat to toast your toast. So when you put your toast down inside, there's all kinds of little wires that run across. And if you looked down into the toaster when the toaster is on, you would see that those wires are growing like an orangey color. And so the heat given off of those little wires is what toasts your toast. But it's the same mechanism in place here. So with the heat, you're also getting that light. Of course, the toaster isn't like your light source. The problem with these bulbs, which is what we're going to put in the other, is that they're not very efficient, which means that most of the energy goes into the heat and not the light. So if you ever touched one of these bulbs after it's been on for a while, they're very hot. And then, of course, the example of the toaster is the purpose of doing that way, of making that little device, is to get the heat off of the wires, not the light. The light's like a side effect. So the light bulb will work to give off light, but it's really, really inefficient. Most of what it's doing is giving off heat. Okay? So we're going to write here they're very inefficient, which is why we have moved away from them, and people are being encouraged to change out those light bulbs for the style we're going to do next. So what that means is they make way more heat than they do light. Okay. All right, let's move on to the next style. So this one is fluorescence. Fluorescency. Okay, so when we make light this way, it's the new style of light bulb, okay, or one of the new styles of light bulbs. So these would look like if we were at school. I would direct you to look at the ceiling, these long ones. Maybe you've seen people change them out before, or even staring up and noticed what's going on in the ceiling one day when you weren't quite so attentive. So they're like the long white ones that would be in institutional places like ceilings in schools, hospitals, those kinds of places. That used to be the only style. Now they've found ways to design smaller ones that you can use in your home. There's a chance you might have some ones like this in your home or in a shop or something like that in some locations for sure. How these ones work is inside of the tube there is mercury vapor, which is why when these ones are done, they're considered hazardous waste. So they're not just supposed to go in the garbage because this mercury element to them, we talked about mercury in chemistry, it's got hazardous properties to it. You shouldn't just be tossing them, and it's not so healthy if you break them. So if it were to burn out, you're not going to smash it up and then throw it in the trash. You want to keep the contents that were in there. You don't want them opening up. You don't want them breaking. So what lines the tube, okay, is a white, we call phosphor, PHOSPHOR powder. And so how this works is that when you run electricity through a tube that has mercury in it, and if we're at school, I could show you this. I think we still have a mercury one lying around. Then it will glow like that sort of white light you associate with those kinds of light fixtures. The white paint kind of stuff, the powder that they put along the inside of these glass tubes, will absorb that and then glow out to make it even more dramatic and allow us to light up spaces. So, these are usually pretty bright, really effective at lighting up a space, but they have a certain color to them. Phosphor materials are good at absorbing energy and sort of glowing with it. In your textbook, which you might read as a follow-up to this, glow in the dark kind of materials, how they work is they have like a phosphor element to them as well. But when their phosphorescence kind of piece to them would be that they absorb the light and then they release it slowly. So you can expose like the little toy or the gadget to light, and then you shut off the lights and it'll glow temporarily, but it won't last forever. Okay, it's kind of the same idea. So to go back to this, what happens is when you put electricity through it, the mercury gets excited, it starts to give off a light that this white phosphor powder absorbs and then glows as well. And you get the nice bright white light. Okay, we now have new ones. I'll try and dry it here on the side. The ones that this is going to be terrible drawing. The ones that kind of coil like this, but can go into like a regular light bulb socket. Those ones are also working by fluorescence. They can make them now so they have another covering, so they look more like the traditional light bulb. I'm not sure what that looks like. It just kind of looks like a real tornado. It's supposed to be those curly light bulbs that you can put in your home now. Okay, so the benefit to this is that they are more efficient, much more efficient. They don't get nearly as hot. They don't waste nearly as much of that electrical energy and heat. So we're going to put here less heat, more light. Oops. Okay, but the downside is, as I mentioned, they are hazardous waste. They will last a lot longer though. Okay, and use a lot less energy. All right. So we've gone from this type of source of light to this one. More and more popular now is what we call the light emitting diode. Light emitting diode, or LED for short. Okay, another pretty common one. So LED lights have been around for a while. They make use of metals again. The advantage to the light emitting diode compared to these other two is it is solid materials. So there's no glass or breakable components like you see with this one and this one. So we're going to put here that it's made from solid, what we call semiconductor materials. I should put here metals. Really, they're metals. Well, they're semi-metals. That's the whole thing. So I'm guessing I'm going to use them in high concentrations because of access to materials and things like that. I might be making that up. But what is great about them is they're very, very durable. So like I said, they don't break as easily. And they're very, very efficient. So they make really good use of the electrical energy and they don't waste anything really in heat. They don't get hot. It's not wasteful in any way. The metals that will be able to conduct electricity and then stop, are really great at responding very, very quickly. So they have a great use that way. And they can be very, very, very tiny, as maybe you're familiar with these little things being used in like computers and phones and stuff like that. So we're going to put here what's great about them is they're very efficient and they're durable. Okay, downside to them might be that they are made of materials that are not so common on the planet. And so the more we convert to this, the less we drain the earth of those resources, and then we need to make sure we reuse them, et cetera, reclaim them so that we don't lose access to it. All right, two more. I'm talking a lot today. Chemiluminescence. So CHEMILUMINESCENCE. Chemiluminescence. Okay, so from this one, the word itself kind of gives the key. It involves chemicals. So you mix chemicals and they give off light. So it is a chemical reaction that produces light. Nice thing is it comes with no heat. So the most common thing that I can think of that you might be familiar with is a glow stick. So when you have a glow stick, some of them are made that like inside, so the main outside is usually plastic, and then inside it is a smaller vial made of glass, and there's two chemicals, one inside the little glass vial, and then one between the glass and the plastic. And then how it normally works is when you're ready to use your little glow stick, you do like the bend, and what you're doing is you're breaking the little glass vial on the inside. That mixes those two chemicals, and when those two chemicals mix, you have light given off, which we talked about before can be a clue of a chemical reaction. So you're mixing two things, and when those things react, one of the things they do to release the energy is give off light. And so that's how a glow stick would work. So one of the benefits of it is that there's no heat. Okay. But it's not really as sustainable to make light as like how we would light up a room or things like that. But it is quite entertaining and fun in lots of uses. There's also a mention that you can use, actually, let's put this example glow stick at crime scenes. So they have a chemical called luminol light, and then that chemical will bond to iron. And iron is part of your blood, as you might know. I think we talked about once before how iron is part of your hemoglobin molecule and how that molecule delivers oxygen. And so some of you that are anemic get tired really quickly, might have low levels of iron. And so you would actually take iron supplements, put iron in your body to boost the levels of oxygen in your blood. So iron is part of your blood. So this molecule, when it binds with iron, produces UV light. And so it produces like a new little molecule, I should say, that can be detected with UV light. So then at a crime scene where there's been blood, to look for trace amounts of blood, things that have been washed up, they can put luminol over the surfaces, and then they bring a UV light in, and the UV light triggers that molecule that's now bound to iron to shine and glow. So that's how they find where the blood was, even though it's been cleaned up. All right. Okay, last one is called bioluminescence. Do you need me?
I'll just sit here.
Okay, I'm almost done.
Okay.
Okay, so bioluminescence, so like this one, chemical, chemistry, biology, life. So this is actually a special type of chemiluminescence. These are living organisms that give off light. Oh, we're all here now. Okay, so what we're looking at is living organisms that give off light. So they are life forms that are able to do chemical reactions when it makes sense to give off light. So, for example, fireflies. You might have been thinking of that one. I get you name some in class. There's a lot of creatures at the bottom of the ocean that do this. I'm going to attach some video for you to look at, reasons why they do that and strategies that have that. They're finding more and more in the natural world too, more and more examples of different forms of bioluminescence. And so sometimes it's not like in the visible light spectrum, but if they shine UV light on organisms, they see all this glowing that those creatures themselves would have been able to detect. So it's pretty cool stuff in there. All right, so I'm going to put over here in other. It's a category of chemiluminescence. So these creatures have these chemicals stored, like the little firefly, things like that. And then when the timing is right, they can release those chemicals, they mix, and you get the little flash or glow. And so organisms take advantage of this ability to make light for lots of reasons, which I'm going to get you to watch in a follow-up video, and you can talk about why creatures would do that. So there's some other examples. I'm going to leave you some textbook pages to read for more depth. I'm going to attach the video, like I said, and leave you some questions to try. I'll attach pictures for those of you that don't have a textbook at home. And there's not going to be a lesson tomorrow. I'm going to have an opportunity for you to come on and ask me questions about any of the stuff I've talked about so far. And then, of course, another little mini lesson on Friday. So this has been a longer one. I apologize. I started with trying to review and add a bit to yesterday and then take you through this new topic. So we will touch base maybe tomorrow if you need me, or just to say hi. And I'm going to leave it at that. You can give me some feedback if this was a better system, just to show you the note. And then I'll move to probably a new way of sharing. I'll still link it to Google Classroom. All right. Let's see.